Good day. So welcome to lecture 2.2 ANOVA 2 ways. So here on the screen shows ANOVA 2 ways. Let's cut the chase and so forgot to bear this one. Let's cut the chase and let's go and see what we have in ANOVA 2 ways. So I've made some scribble here first. So this is the one that we have not seen before. Why do we study ANOVA 2 ways? Right, for ANOVA 2 ways, we actually have why it is called 2 ways, because it has two factors, A and B, right? Factor A and factor B. In ANOVA 1 way, we only have one factor, which are the, let's recall back to our ANOVA 1 way lecture. It's about the cotton strength. So this we have one factor, and we have many levels. What are the levels for them? The 15%, 20%, 25%, 30, and so on, right? For ANOVA 2 ways, there are two factors, and for each of these two factors, there will be many levels. The minimum will be 2 levels, and you can have more. And the most interesting part of ANOVA 2 ways is number 3 there, as you can see on the chart, is the interaction. What is the interaction? Between two factors, it is interesting to see if there are any interaction involved. Let's say you see there PV equals to T, which is the ideal gas equation, take out a lot of things. Let's say I take out V because I just want to have two factors, P and T. Right. The blue arrows go up means anytime P goes higher, T goes higher as well. Anytime pressure goes lower, T goes lower as well. So these are the kind of interaction that we are looking for, or we are looking at. On this graph, it says that both factors have two levels, a high and a low. Of course, you're not going to produce this in an exam. This is very simple. What we're going to use is the one that is in the formula sheet, right? So technically, you have two factors, and these are the ways to see it. Now, the next graph that you must build for ANOVA 2 ways, unfortunately, is the response graph or the interaction graph. On the y-axis is the response, whatever you get, and on the x-axis is factor A. So the plot one is factor B. So the question is, please plot B against. Please, wait a moment. Right, I have to use out of battery now. Okay. Okay, let's get it. Sorry, yeah. I don't want to cut that. It's too much work. For y-axis, it will be B plot. So as you can see here, these two lines denoted by the green lines, they are not crossing. That means there's no interaction between them. That means this experiment between factor A and factor B, there's no interaction exists. So the calculation, which are not these calculation, right? But I want to discuss about the answer. For factor A, you see here it's 21, factor B is 11, and AB, which is the interaction. Symbol for interaction between A and B is AB, just like the vector equation, yeah? You have the same one as in ANOVA 1 way, which is the positive give good yields, negative piece go down yields, and interaction less than 1 or maybe less than equals to 1 means it is almost non-existent, right? Just like the graph tells you. Okay, now let's go to the next slide. These slides interestingly have interaction between factor A and factor B, right? B. There is an interaction. Let's take a look at the results of calculation. The results here shows you that factor A is 1 positive, 9 negative for B, and negative 9 for AB. That means which one of these is the main factor? For the one that we see before this, A is our main factor because it has the highest magnitude, which is 21. But for this one, the main factor is B. Even though B is negative, but still it is the highest magnitude, right? Negative just means that if you have B high level, the results will drop. And as you can see there in the interaction, if you combine A and B, you have a very, very bad interaction, right? And negative field, if positive is what you are looking for. Understand? All right. Now, these are some of the new symbols that you must see. Small a is level for factor A, small b is level for factor B, and you must replicate, and this is n of course, and you have interaction that's going on there. Right, these are the videos that I cannot show you because this is recording. Maybe I can show you later on when we have tutorial or when we have class together. Okay, let's go straight to my dearest friend. Okay, this is Kathy. She's no more cotton engineer. She's now a hybrid car engineer. What is she studying now is about these batteries, the lump sum fuel batteries, yeah? Lump sum fuel batteries. And this battery will be put inside a new electric car and it's going to drive them in 3 different conditions. Why? People drive in the winter, people drive in the temperate climate, and people drive in the desert, let's say. So, with this, you have 2 factors, the temperature and not the car. The car is dry. And the batteries. Okay, the batteries. So, we will subject this into 3 types of batteries, type A, type 2, type 1, type 2, type 3, and 3 different temperature. -9 degrees Celsius, 21 degrees Celsius, and 51 degrees Celsius. Coldest, normal, and the highest. Alright, the hypothesis will be, now in case of hypothesis quite different than ANOVA 1 so it is not all the same, or it's not one different, or between 2 groups are the same, no. So I'm going to discuss it at the end of the case study, yeah? So you have to wait for a while. Okay, now the research question, because all question must have objective. So what is the objective of the research question in this case? The first one, what type does what effect does material type and temperature have on battery life? Does it increase the battery life? Does it reduce the battery life? And number 2, is there a choice if I can combine this material, maybe 1, 2, and 3, I combine them and make a better battery out of it? So these are the things that she's looking for in this study. Alright, so let's keep to the calculation part. Now, here is the calculation. It's very, very long. Right? How many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 marks? I'm not sure. Usually, for ANOVA 2 ways, I leave them as maybe these 3 is blank. So from all these given, let's say all these are given, what are the 3? So I just give 3 marks. I always like to ask evaluation question with ANOVA 2 ways. There goes my tips for exam. Alright, so this is the case study. The temperature, although in degrees Fahrenheit, is the same as degrees Celsius. This is -9, this is 21 degrees Celsius, and this is 51 degrees Celsius. We have 3 types of battery, right? We name this A, factor A, and name this as factor B. Usually in the final exam, I will name this. A is material type, A is temperature, whatever. So you just follow that one, yeah? So for each of this group, let's say she combined type 1 battery and -9 degrees Celsius, and from there she has 4 replicates, 4 batteries, or 4 times she do this experiment, she get these live batteries in hours. The first one maybe 130 hours, and then 74 hours. So go up and go down. So you have almost 9 groups, 4 replicates for all of the combination, right? So what do we see from there is this. These are the calculation part. Alright, so stay with me. Okay, still recording. Good, you see my Spider-Man. Okay, what are these circles? What are these circles? These circles are the summation of all the groups in that group, or of all the live hours in that group. That means 130 plus 155 plus 74 plus 180, and you get your 539. And this one will get this one will get this, right? That's the first job. Then this one must have this result. If you sum 539, 623, 576, you got 1738, and such this way, and of course this way as well. And this is the grand total. 3799 is the total of rows and column. They must tally. If they don't tally, then you are in deep trouble. That is our first job. And next is, of course, to put it in the equation. Alright. Now here is your SST. This is the summation for A, B, and N. Small a for level of material, small b is a level for temperature, and N is the repetition, I, J, K. Right? Therefore, for SST, you must do all the points there, everything. Square them first, and then plus them, and minus with the grand total and everything, 36, and you got a positive value. Let me zoom out. This is A, this is B. Right, for AB, you can see here inside here is B and this one is A. So importantly, you must follow this equation, right? So this is 998, 1300, and 1501. This one is 1738, 1291, and 770. Where do we get this from? From this. You can see that all these columns, this, you square them. For this one is for A, and this one is for B, the temperature. Alright, then you must do the interaction now. Interaction is 1 over n, to replicate, that's why it's 4. And these numbers are the circles that you have calculated before. These circles, right? I'm going to change to the red color. These circles, square them and plus them, because this will give you the interaction value. So as you can see, all our values are still all positive. And in the end, SSE is the error minus all of these. And you got a positive value as well. Next slide. I'm going to go this very quickly because they are mostly the same as ANOVA one way. Okay, so all this data, you can let it down in such of these, right? And this one no need to take care of because this is for another class. And you can see here that these are the result of your F0. Now take a look. The first things first, positive value. All of them have positive value, right? That means all of them are good. They have good outcome individually. Next, all of them is more than 1. That means happen. It happened in this experiment, right? Which one is the main factor? This one, B, is the main because it has the highest magnitude, 28.97. That means temperature is your main factor. You change a little bit of temperature, the whole experiment will change eventually. Alright, let's go for the evaluation part. Right, I'm going to make this very short, shorter than the ANOVA one way. So I have explained to you just now. Right, this happens, right, and it's more than 1. That means B is your main. P value we don't want, and it's more than 1. That means they're happening. Now, we need to take a look at this and compare it with the table. Right, table. So as you can see, our material type and temperature have same degree of freedom. However, the interaction is 4. For material type A and B is 2 and 2. Therefore, you must find 2 times. One is this, the one I circled just now, and the one is this one. You see? So what are these? Alpha, V1, V2 from the table. Alpha, V1, V2, and you get these results. So if you're still not sure how to find this, we'll do this in the you will see this in the tutorial session. Yeah, so all these results, 3.35 as well as 2.73, they are all more than they're all less than the one that you get from the F0. That means all of these are H1 accept. What does that mean? It means green. It means they are all significant. Don't change them. Don't change them, right? If, let's say, if H0 accept, then you can change them as you like because it is not significant. So that is the best part about ANOVA 2 ways. You can see which one is the main, which one need to be changed, which one happened in the one shot of simple experiment. Now you have to build a response graph. Where do you get this data? So this one is a material versus temperature. The one that you see here, the one I dot red, comes from the table. What table? This one. These results, yeah? You see this 539? All this divide by 4. Why 4? Because you have 4 repetition. There. 1, 2, 3, 4. Divide by 4. Divide by 4. Therefore, you will have an average life. In this case, laid down in this graph. As such. Ta-da! Very easy. Easy peasy. Lemon squeezy. Now, she wants to choose the best material. She says she will choose type 3. Why? Because, change to blue. Material type 3 have overall average, have the highest point in the life response, or the response of life, battery life. That means material type 3 is the best to drive in any case. That's number 1. Number 2, if you can combine them, because maybe type 3 is expensive, type 2 is less, and type 1 is even is the least of any price cut. So you need to see whereby we combine this is the best. In this part, you can see that there are 2 interaction happens. The first one here on top here is between material type 3 and material type 2. The one below here is between material type 1 and material type 2. If the question asks, if I want to send this to those who drive in the region where it's between winter and moderate summer, then material type 3 and 1, sorry, not this color. Material type 3 and 2 is the best for the combination. This, If I want to drive this in a very hot climate, then material type combination of 1 and 2 will be the best to cut costs. So we'll see this more in the tutorial session, but this is what ANOVA 2 ways looks like. Okay, so it gives you if the interaction happens, it's not happens. So in this case, yes, it happens. And also explain in the calculation that the interaction is more than 1. Okay, good. That's it for ANOVA 2 ways. Thank you for listening to my video, and I'll see you in the next one, and I'll see you in the tutorial session as well. Goodbye.